Chris here. I want to talk about topology. Topology refers to the edge flow of the model and sort of the cleanliness of the model and how it is put together. If I look at this plane here, it consists of one polygon, and this polygon has four sides to it, right? 1, 2, 3, and 4. And this is what we would call a quad. And quads are sort of the ideal polygonal shape that we want to work with. The main reasons why we like quads so much is that they are predictable, they do not interrupt edge flow, and they are easily subdivided. Now, if someone were to say, oh, what's your try count, right? TRI, try, that is just short for triangle, right? So now I have two tries here. Right, so 1, 2, 3, three-sided polygon is a try. Now, let's say I had something like this, and I came over, and let's make this a little more obvious. I'll just move this like this. So I have a bunch of quads all over the place, and here I have a face that has more than 4 sides, right? This has 2, 4, 6 sides, and this is called an ngon. So any face with more than 4 sides is an ngon. And most of the time for real-time engines, we do not want ngons. We want quads or triangles, okay? You will get ngons as you're modeling, and it is your job to clean them up. And there are a lot of different ways to clean them up. Once you spot an ngon, this example here, I could do something like this. I could take my multi-cut tool and I could close this up, and now I have 2 quads. I could, if I was really confused, sometimes I like to delete the ngon, and then I could start bridging to close it. And other times you may want to use the target weld to solve the ngon problem. But every situation will call for a different tool to fix. So there are several reasons why we don't want ngons, and one of the main reasons is that it breaks edge flow. So if I were to come over here with my multi-cut tool and hold control, you can say, oh, I can drop an edge loop that goes from one side of the model all the way to the other side of the model, no problem. I could do it this way as well. If I went over here, you can see that my edge will not extend all the way across the model because it is broken by this ngon. So there's no directionality to this polygon. The reason why we move in this direction is because it's a bunch of quads connected to each other in a predictable manner. Here, not so much, right? So if I have an ngon, it will break the edge flow. The same thing will happen with a triangle. So if I were to have a triangle here, and I try to drop an edge loop, you'll see that it won't connect all the way around because it is being broken by this triangle here. Typically, when we bring a model into a real-time engine, it is going to triangulate it. And if we have an ngon, we are not necessarily controlling how it triangulates. So if I were to triangulate this inside of Maya, I go to Mesh Triangulate, we can see what happens. So wherever there are quads, we get these nice predictable triangles. And then here we have the ngon, and we've created this pretty gnarly pole here. Yeah, and so we don't want this. We always want to be in control of where we are putting our tries and avoiding poles like this. So that is a brief description of what a try or triangle, quad, and ngon is. To search for ngons, you can select the model and go to Mesh, click on the option box for cleanup, and here we have the cleanup options. By default, it'll have this cleanup matching polygon selected, this radio toggle, and we want to change that to select matching polygons. And then fix by tessellation, I want to check this box that says faces with more than 4 sides. Hit apply, and it will highlight any ngons that you have. So as you're modeling for real time, you should continually check for ngons every once in a while and, fix them. Let's talk about other troublesome topology. So the first one that we'll talk about is non-planar. And a non-planar face or a non-planar polygon is one that is bent. So if I were to take this vertex, for example, and move it up and over, you can see that now I've bent this polygon, right? If I turn the camera angle, we can kind of see it here. From this vertex to this vertex, there's a crease here, but there's no edge to support that bend. So this is called a non-planar face. And you can run into problems with various operations if you have non-planar faces. Also, if your model is being rotated around and looked at, non-planar faces tend to stick out quite dramatically, and they can create issues with lighting. So if you must have a polygon like this, the easiest fix in this situation would be to just give an edge where that crease is. So I would multi-cut from here to here and right click, and now I've fixed that. So I'm created 2 tries instead of the non-planar face. The next term is called non-manifold geometry, and you most of the time you'll run into this when you're trying to UV unwrap your model. And non-manifold geometry typically is when you have an edge that shares more than 2 faces. So if I were to take this edge and extrude it out like this, now I have non-manifold geometry, and that just means that Maya, when I'm UV unwrapping this, would not know how to unfold this, right, and lay it out flat. So you want to avoid this type of modeling. You never really want to have an edge share more than 2 faces like this. And most of the time the fix for this would be to come and find the non-manifold face and delete it. And typically when I run into this, or I see students run into that problem, there are faces, non-manifold faces on the interior of the model created from improper extrusions. Every edge has, and every face has direction to it. If I were to take my multi-cut tool, as described before, I could easily see the direction or the edge flow of the model by looking at the edge loop preview as I hold control and click and drag, right? So this is looking predictable. Let's say I create an edge like this and do something like this. Now I've just changed the direction of this edge. So I have all quads still, there are no triangles. And if I hold control here, you'll see that the edge flow now turns in that direction. We'll talk more about edge flow and turning your edges in another video, but just know that edge flow is important, and the edge flow should follow the forms of your model. And that's it. In the next video, we will talk about smoothing in greater detail. See you there.